Okay, let's look at a couple of solving a right triangle examples. So solving a right triangle means find everything, all three angles, all three sides. And they're always going to give us three pieces of information, and we're going to have to find the other three every single time. So here's a right triangle. We know across from angle A is little side little a, across from angle B is side little b, and the hypotenuse across from capital C, that's a big C there, is little c, or a hypotenuse. And we're given this information. So let's go ahead and put that in our table. Our answer here, when somebody asks you to solve a right triangle, your answer is an entire table. All three angles, all three sides. Make sure you write your capital letters different from how you write your lowercase letters. This causes a lot of problems. If you mix up your angles and your sides, you're going to have a bad time. So my angles are capital letters, my sides are lowercase. So I'm told side A is 20 degrees. I know C is the right angle, that's 90. And I'm told little c is 12 feet. Notice I'm always going to write degrees on all the angles. And I'm going to write units, in this case feet, on all the sides. Okay, now we want to find the other three pieces of information. Well, first, we know all three angles add up to 180, so I could do B is 180 minus the two I already have. Or, like alternatively, which is probably easier, these two will always add up to 90. They're always complementary. B is always going to be 90 minus A. So 90 minus 20 is 70 degrees. Now, what I recommend when you're filling out this table, anything you found yourself, put a box around as a reminder. I found that one. Okay, now let's get into finding A and B. And we've got a bunch of choices here. Sometimes people get overwhelmed because there's so many different ways to find these. So I'll write down a few different ways. I could say, for example, write down sine of angle A. Let's write it down and see what it is. Sine of A will be opposite over hypotenuse. Let's look and see what we know and what we don't know. I know angle A. I know C. I don't know little a. So I know 2 out of the 3 in this equation. I can solve for little a. I can multiply this little c over. So little a will be little c times sine of capital A. And I've got this fancy calculator. Little c I know. Clear all this. So I want 12 times, make sure you're in degree mode, sine of 20 degrees. Capital A was 20 degrees. And let's round to 2 places. We'll call that 4.10. So let's put that in our table here, 4.10. Feet. Don't forget your feet. And since we found that one, let's box it. Or, see, that was not the only choice. Or, I could have done, I don't know, cosine of B. Cosine of angle B will be adjacent over hypotenuse. I know angle B. I know side C. And let's pretend we haven't found A yet. I could use this to find little a. So just cross multiply the C over. Little c times cosine of angle B will be side A. So let's get our calculator out and try that. Let's see if it works. 12 times cosine of 70 degrees. I'm on angle B now. And like we know, these are cofunctions. Sine of one angle is the same thing as the cosine of the other angle. I know I'm going to get the same answer. So let's write it here just for completeness, but it's the same thing. Or I could have done tangent. I could have said tangent of A is A over B. So let's pretend we didn't know little a yet. What if I wrote this down? Tangent of angle A will be little a over B. I know angle A. And again, let's pretend we hadn't already solved for little a. If I didn't know that, I also didn't know angle B. I still don't know it. This one, it's true, but wouldn't have helped me. So sometimes you got to write down more than one of your trig functions until you find one where there's only one unknown. That would have had two unknowns. So that would not have helped. It would be true, but wouldn't have helped. Okay, so now we found little a. We found it two different ways. Now let's find little b. I've got a bunch of choices. I could do... So let's say here what we're doing. Now let's find little b. I could say sine of angle B is little b over c. And honestly, that's the way I would do it. Sine of angle B is opposite over hypotenuse. I know angle B. It's right there. I know side C. I can solve for little b. Or I could do cosine of angle A. That would also be little b over c. I could do what I did a minute ago. I could do tangent of angle A and get little a over b. Now this one's going to be mathematically more complicated because the guy I want is down here in the bottom of a fraction. I know a. At this point, I do know little a. I know it's 4.10. But now the guy I'm after, little b, is down here in the bottom of a fraction. I'd have to do some cross multiplying. Like maybe for fun, we'll finish that out and do it. But there are a bunch of choices. Or, let me write an or here. I could do Pythagorean. This is a right triangle. I could do a squared plus b squared equals c squared. And in fact, maybe I should do more than one just as a check. That's a good check. At the end, do Pythagorean and make sure it works. I'm going to do the first one. I'm going to do sine of little b, or angle b, sine of capital B is little b over c. So we're going to think of this as just over 1 and cross multiply. C times sine of b is little b. And I just prefer to have the guy I'm looking for on the left, so I'm going to write that the other way. What was little c? Remember, this is side c, not angle c. 12 times sine, and angle b was 70 degrees. So 12 times sine of 70, 11 point, let's say 28. Feet. I want to have units here. Let's go ahead and put that in our table. What was that? 1128? Yeah. And since we found that, let's put a box around it. And again, we could check this using Pythagorean. Okay, but just for fun, let's do this other way right here. Tangent of A is little a over b. So think of this as a proportion if you want, and cross multiply. So b times tangent of A will be little a, so b will be little a divided by tangent of angle A. I like to solve it algebraically first and then plug in my numbers at the end. A lot of people like to write their numbers up in here, but it's much better solve it algebraically first and then write it with your numbers. So what was little a? 4.10, that's an ugly 4. Let's write that a little prettier. Over tangent, and angle A was 20 degrees. So 410 divided by tangent of 20 degrees. Oops. Notice we got a slightly different answer. Why is my answer different? Because that 4.10, that's not what A was. A went on forever. A was some big, long, nasty decimal. I approximated to get here. So that we call that rounding error. That's going to compound. If I use something that was an approximation to find the next thing, it's going to be even more approximated. So doing this, I get 11.26. Now, in this class, doesn't matter. Either way, if you wrote this on a test, I'd give you full credit, especially because you have to write your work anyways. In the real world, though, we want to avoid what we call compounded rounding errors. So in the real world, you would not want to do it this way because that 410 was an approximation. Doing it this way, these were all exact numbers. So this is going to be a better answer than this is. So anybody that's going to be an engineer, don't use anything that was approximated to find something else if you can avoid it. Sometimes you can't avoid it. In this class, don't stress about it. This would be perfectly fine. Okay, something else I want to point out. This is something you should always check. Which is our smallest angle? That's angle A, right? 20 is the smallest. Notice that goes with the smallest side. And the biggest angle, 90, goes with the biggest side. And the medium angle, the one in the middle, goes with the middle side. That will always be true. If you ever solve a triangle and that's not true, you've done goofed. Your smallest angle always goes with your smallest side, biggest angle with the biggest side. And there are multiple ways to find many of these different sides and angles. Okay, let's do another example. Okay, so we have this example. We have this right triangle. We want to solve a triangle. That means find all three angles and find all three sides. And all we're given here are two sides, and we're always given the right angle. Like we always have, capital C is 90 degrees. So we'll always be given three pieces of information, but this time they gave us two of the sides. So let's fill in what we know. Remember, our final answer, if we're going to circle something, it's going to be this entire table. I know capital C, angle C is 90 degrees. Don't forget your degree symbol. I know A is 8 meters. Don't forget your meters. And B is 10 meters. Let's find side C next. We don't have to. We could find A or B first, but let's find side C. Well, we know C squared is A squared plus B squared, Pythagorean. So C squared will be 8 squared plus 10 squared. So C squared is 64 plus 100. So 164, but nobody asked me for C squared. I want C. C then is the square root of 164. And let's go ahead and approximate that. I've got these fancy calculators. Square root 164. Oops. It's going to work better if I type the right number. Let's call that 1281. We'll round to two places here. And that was meters. Let's put that in our table. And since we found it, let's circle it. Okay, now we're going to have to find our angles. We're going to have to use an inverse trig function. So I could, for example here, let's just write this down and see if we like it. I could say sine of A will be opposite over hypotenuse. I know little a now. I know little c now. I don't know angle A. I could absolutely do this. But remember what we said a minute ago? That was an approximation. So let's try to avoid that. Let's try to use the guys we know. Again, don't stress about it. If you did it this way on a test, I would give you 100% credit. It's just not going to be as exact if we could avoid using this guy that was an approximation. If we could just use these guys. So let's look here. Here's little a. Here's little b. And little c. Which of our trig functions would use these two sides? Well, tangent would. If I did say tangent of angle A, that would be opposite over adjacent. So this is perfectly fine. That's okay. But instead I could do tangent will be opposite from angle A over adjacent. I know both of those exactly. Now I can find angle A. So tangent of angle A will be 8 over 10. I'm looking for the angle. I don't know the angle. I want to undo this. Remember, that's not tangent times A. That's a common mistake. I can't just divide both sides by tangent. That's tangent of A. I want to invert that. I want to undo that. So I'm going to take the inverse tangent. That looks like this. We're going to spend an entire class on inverse functions later. But this is the button on our calculator. It's called inverse tangent. We're going to take that of both sides. So I want the inverse of the function evaluated at A. And that should be the inverse of this fraction. So I just applied. I didn't multiply. I applied the inverse function to both sides. The inverse tangent of the tangent, these will cancel out in this case. And I just get A is the inverse tangent of 8/10. So if you have trig function of angle equals a fraction, you do the inverse of that fraction to get the angle. And we have that button on our calculator. It's right here above tangent. If you look above tangent, there's a little tangent with a little -1 there. That's not 1 over tangent. That would be cotangent. That's inverse tangent. It undoes. It gives you the angle whose tangent is 8 over 10. So I want to do inverse tangent. See, look at him right there. Little -1 there. Of 8 over 10. Hit enter. And that gives me an angle. So 3866 degrees. Don't forget your degree symbol. Let's put that up here in our table. Is that 3866? Yeah. And since we found that, let's put a little box around it. Now, how could I find B? Well, I could do, if I wanted to, tangent of angle B is little b over C. I could do sine of little b, or sine of angle B is little b over C. I could do cosine of angle A would be little b over C. And then do an inverse cosine. Or, remember, these two angles here, A and B, are always complements. They add up to 90. This is always going to be true. That B, angle B, is 90 degrees minus whatever you got for A. That's always true. So we throw that in our calculator, and like I could just type what I wrote there, or I could just do 90 minus, 90 minus my last answer. So I need to get to answer there. Second answer, 5134. Degrees. Don't forget your degree symbol. Don't forget to come up here and put it in your table. And box the ones you found yourself. And then as a quick check, your smallest angle, that's the 38 degrees, matches up with the smallest side. The biggest angle goes with the biggest side. And that's a good place to stop.